Over 3,000 meters below the ocean surface, where sunlight cannot reach and pressure would crush most objects flat, lies an unlikely discovery. A luxury automobile, sleek, engineered for speed on dry land, now rests among the silent inhabitants of the deep. But this is no accident. What you're witnessing is one of the most ambitious and technically challenging recovery operations ever attempted. A meticulous dance between man and machine, played out in an environment where a single mistake could mean catastrophic failure. After years submerged in saltwater, the vehicle has become a living museum. Marine organisms, barnacles, algae, and countless microorganisms have claimed it as their own, creating a calcified shell that tells the story of its time on the ocean floor. The corrosion alone presents a formidable challenge. Saltwater is nature's most efficient destructive force, transforming steel and aluminum into brittle shells of what they once were. Engineers must work quickly, but carefully. The wreck's structural integrity is compromised. One careless movement could cause the entire vehicle to collapse. Enter the deep-sea salvage team. These are not ordinary divers. They are specially trained technicians who operate in an environment where conditions can change in seconds, where equipment failures mean certain death. Each diver wears a pressurized suit capable of withstanding extreme depths. Their movements are deliberate, almost choreographed. Communication with the surface is constant, a lifeline of information flowing through umbilical cords that carry air, power, and data. The task before them is deceptively simple in concept: secure the vehicle and prepare it for ascent. In execution, it demands absolute precision. They must assess load-bearing points, identify structural weak points, and determine the optimal positioning for lift straps. The first phase of any salvage operation is comprehensive assessment. The team documents every detail: how much sediment has accumulated, which structural elements remain sound, where is the center of gravity. A single miscalculation in weight distribution could cause the vehicle to tilt during ascent, potentially shifting its center of mass and creating an impossible burden on the lift system. Each measurement is taken multiple times. Each structural element is tested and verified. The diver's gloved hands move with practiced efficiency. Despite the restrictive suit, every action requires exponentially more effort at depth. Fatigue is not just uncomfortable, it's dangerous. The team works in short rotations, with fresh divers replacing those who've spent their time limit in the hostile environment.
Now comes the critical phase: rigging. Reinforced steel cables and specialized lift straps must be carefully threaded through and around the vehicle's frame. These are not ordinary chains. Each one is engineered to handle stresses that would snap conventional materials like thread. The placement of these cables is everything. They must distribute the vehicle's weight evenly as it's lifted thousands of meters upward. Too much stress on one point, and the metal will tear. Too little support in another, and the vehicle could rotate uncontrollably. The team uses a quadrupoint lift system, 4 cables positioned at precise angles, each one bearing an equal share of the load. In theory, it's straightforward. In practice, working at depth with visibility often reduced to just a few meters, it requires extraordinary skill and focus. Above, on the surface, an entirely different operation unfolds. A specially equipped heavy lift vessel maintains position above the wreck site. This ship is equipped with massive A-frame cranes capable of lifting hundreds of tons with millimeter precision. The vessel's position must remain constant, despite ocean currents and waves. Dynamic positioning technology uses computer-controlled thrusters to hold the ship in place with GPS-level accuracy. A single slip in positioning could translate to catastrophic tension on the cables far below. The crane operator is in constant communication with the dive team. They cannot see what the divers see. They are operating on trust, experience, and real-time data transmitted from the seafloor. The operator's hands move slowly, deliberately, taking up slack in the cables with painstaking gradualism. The moment of truth arrives. The crane begins to lift. The cables grow taut. Sediment that has surrounded the vehicle for years is disturbed, creating a cloud of particles that obscures vision. It's as if the ocean itself is resisting this intrusion, this violation of its domain. Pressure on the cables reaches critical levels. Every system is monitored in real time. Sensors report back load balancing nominal, cable tension within parameters. The vehicle rises slowly, inexorably from the darkness toward the light it hasn't seen in years, but the danger is far from over. As the vehicle ascends, water pressure decreases. This change in pressure could cause trapped air pockets within the structure to expand unpredictably. The divers remain vigilant, watching for any sign of instability or catastrophic failure. The ascent continues for hours. Time moves differently at depth. Each meter gained is hard-won. The vehicle rises past the point where light from the surface becomes visible, into the twilight zone where bioluminescent creatures represent the only illumination. The team has rehearsed this moment countless times. They have planned for contingencies, prepared backup systems, and trained for emergency scenarios. But no amount of preparation can fully account for the unpredictability of the ocean, and yet the vehicle continues upward, cable by cable, meter by meter. The divers monitor the rigging from below, watching for any sign of failure. Above, the crane operator makes microscopic adjustments, keeping the load perfectly balanced. Then, after hours of tension and meticulous work, it happens. The vehicle breaks the surface. Water cascades from its form as it emerges into air for the first time in years. On deck, the support team is ready. The vehicle is secured to the ship with secondary rigging systems. Cables are released one by one. The wreck is carefully lowered onto cradles designed specifically to support its weight and protect its structural integrity. What emerges is a testament to engineering in the most hostile conditions. The team steps back. The operation is complete. The impossible has been accomplished. This recovery operation represents the pinnacle of human engineering and determination. It required specialized knowledge, advanced technology, unwavering courage, and perfect coordination among dozens of experts working across two vastly different environments. The ocean depths remain one of Earth's final frontiers, beautiful, mysterious, and unforgiving. Every object we retrieve from those depths tells a story of human perseverance, of our drive to overcome nature's greatest barriers. This is the story of an extraordinary feat, a reminder that when faced with the impossible, human ingenuity, skill, and teamwork can achieve what once seemed beyond reach.